the second part of this lesson, we're going to find area of triangles, and we're going to have two different situations. The first one does use trigonometry. The other one is actually just a theorem that you use that's helpful if you know all three sides of a triangle. So let's jump in here. Number one here, we're supposed to find the area of each triangle to the nearest tenth. So we know that area of a triangle is 1/2 base times height. So we go to plug things in. Area equals 1/2 the base. Looks like that's going to be 11.6 times the height, but we don't have the corresponding height to that base. So this would be the height right here. And we need that in order to find the area. Well, we do have some other information here, and we have a right triangle that has this height involved. So if I'm going to trace out the triangle we're going to work with here, this blue triangle, and we want to find h. Now realize this 11.6 is for the whole triangle, the bigger triangle, not the one we're working with. So we want to find h, and we have this 20-degree angle. We have the hypotenuse of the right triangle. I know it's not a hypotenuse in the original triangle, but the hypotenuse of the right triangle is 10 yards. And then we have this value h over here, which as we're thinking through that, that is the opposite leg of the 20-degree angle. So we have the hypotenuse and the opposite leg. And so when we have hypotenuse and opposite leg, think of SOHCAHTOA, and we see that we want to use sine. So again, we need to find the height for this spot right here, and so we're going to use trigonometry. So we have sine of the angle, which is 20, equals the opposite leg, which is h, over the hypotenuse, which is 10. As mentioned before, we can multiply both sides by 10. We actually don't have to find out what the sine of 20 is. We can just work through this, multiply both sides by 10 for this to cancel. If you are more comfortable with finding sine of 20 first and write it in there, that's completely fine. But 10 times the sine of 20. So I'm going to type that in over here. 10 times the sine of 20 is equal to 3.42 and that's equal to h. And now that we know h, we can put it in for the height. And now we can find the area of the triangle. So we used our area of the triangle, 1/2 base times height. We knew the base was 11.6. We needed to use trigonometry to find the height. And now we can multiply this out. So we have 1/2, so 0.5, times 11.6 times 3.42. And we get 19, it said round to the nearest tenth, so 19.8 yards squared. All right. The next thing is called Heron's formula, and this is used when you know three sides of a triangle. It doesn't have to do with trigonometry. That using it doesn't have to do with trigonometry. It just helps us find the area of a triangle. So I'm going to shrink this down so you can actually see what Heron's formula says. The area of a triangle with side lengths A, B, and C is given by area equals the square root of s times s minus a, s minus b, s minus c. Remember, those are the side lengths. But we need to know what this s stands for, where the semi-perimeter s is half of a plus b plus c. So semi-perimeter just means half the perimeter. So it's pretty straightforward. So we want to find this area using Heron's formula. It's going to be the square root of s. Well, we need to find s. So S is the semi-perimeter, so let's say the perimeter, we'll find the perimeter first. That's going to be adding them all together, 9.6 plus 6.2 plus 12. So the perimeter is going to be 27.8 if you add those together. So the semi-perimeter is going to be half of that, 27.8, so I think that's 13.9. So the semi-perimeter is 13.9. So we want the square root of, and we're just going to plug everything in. So A, B, and C are the sides, so we can say maybe this is A, B, and C. So we have semi-perimeter, 13.9, times 13.9 minus 9.6. So that's S minus A. And then we'll do S minus B. That's 13.9 minus B is 6.2. And then 13.9 minus C, which is 12. And you actually can put this in your calculator all at once. If you're not comfortable with that, you can do it in different parts. We'll do that for right now. So 13.9 minus the 9.6 is 4.3. 13.9 minus 6.2 is 7.7. And 13.9 minus 12 is 1.9. Again, you could put all this in your calculator. So let's do that. Again, you could have done it up here. Just make sure you use parentheses correctly. So I'm actually going to get rid of this one here, and I'm going to go ahead and type this into the calculator. We want the square root of 13.9 times, so notice when I hit times, it still remained under the square root, 4.3 times 7.7 times 1.9. And now we can come out of the square root, hit enter, and the answer is 29.6 centimeters squared. So that's Huron's formula. Pretty straightforward. Just find the semi-perimeter, plug that in.